So we have already discussed, as per Hooke's law, stress is directly proportional to strain. So we are equating it as stress is equal to K into strain. So this K is called as modulus of elasticity. This K decides what is the characteristic of a material. This K decides until which point a particular material, if we construct a bridge, until which point the bridge can, how many members at a time can stand on this bridge without collapsing. And similarly, this K decides when we design a machine like any vehicle like aeroplane or ship, different whatever the machines we design, engineering machines. So this K is useful while constructing that. Now we will go in deeper discussing about this modulus of elasticity. This K, if we take longitudinal stress by longitudinal strain, so longitudinal stress for the time being, I am representing with sigma. This is the Greek letter, and epsilon. This is the longitudinal strain. We are representing with epsilon. So this epsilon, sigma by epsilon is nothing but modulus of elasticity. But this particular modulus of elasticity, longitudinal stress by longitudinal strain, I am representing with Young's modulus with a letter Y. So this Young's modulus is modulus of elasticity only. Particularly, we are giving a name as Young's modulus because it is discussing about longitudinal stress by longitudinal strain. Okay, what is the unit for this Young's modulus? There is no unit for strain. Why there is no unit for strain? Because it gives the information between delta L by L. Delta L means length. So numerator length, denominator length. So there are no units in the strain. Epsilon, here no units. But there are units for sigma, which is stress. Stress is equal to force per unit area. The unit for force, Newton, and unit for area, meter square. So Newton per meter square is the unit for stress. So that is the unit for modulus of elasticity, and that is the same unit for Young's modulus. So Newton per meter square, we also call this as a Pascal. In order to give the tribute to the scientist who had done phenomenal work for the science, we have given his name as a Pascal unit for force per unit area. So either we can call the unit for the Young's modulus as Newton per meter square or Pascal. The unit for elasticity, modulus of elasticity also Newton per meter square or Pascal. See, we will take some four materials. The first material is aluminum, and the second one is brass, and the third one is copper, and fourth one is steel. We are trying to increase the length of a steel wire. What is the cross-section area of that steel wire? 0.1 centimeter square. So how much length we are trying to increase? 0.1% length. So in order to increase the length by 0.1%, we have to apply 2000 newtons force. For aluminum, to increase the 0.1% length, we have to apply only 690 newtons. Whereas for the brass, 900 newtons, whereas for the copper, 1100 newtons required. So in all these four materials, you can observe, in order to increase the length of a steel material, we have to apply 2000 newtons force in order to increase the length 0.1%. So it is, if we see the numerical statistics, you can observe here, the Young's modulus is higher for the steel, whereas the Young's modulus out of these four materials is low for the aluminum. So it is difficult to change the length of the steel. It is easy to change the length of the aluminum. So the stress, whenever the restoring force per unit area, if we take for the steel, if we have to increase its length by 0.1%, we have to apply more force. And for aluminum, it is we can, with the less force only, we can increase its length by 0.1%. And then that's what we are naming as yield strength. Yield strength is high for the steel and yield strength is less for the aluminum. This is the reason we use the steel for the heavy duty machines. And whenever we construct a heavy structural design, we will not prefer the aluminum, we prefer the steel.